Welcome to the routing security or securing routing session at Apricot 2021. I'm sharing this session together with Tashi. But first, a couple of brief notes on housekeeping. Please be mindful of the code of conduct, which is being pasted in the chat box. And if you want to ask a question or make a comment on the session, please use the Q&A button on Zoom for text, and I'll read out your comment or question, or make Tashi do it. You can use the Zoom chat for any questions you have about the events. And if you are participating in social media, please remember to use the Apricot 2021 hashtag. Without further ado, I'll introduce Tashi, who is co-moderating or co-chairing this session with me. Over to you, Tashi.
All right, thanks, Philip. Welcome everyone to this session. In the interest of time, let's directly jump into the program. Kicking off the session today, we have Melchior from Juniper, who will be talking about tcpao making more sense than TCP MD5. So Melchior, floor is yours.
Hi, good morning, good afternoon, good evening. Thanks for having me. Let me share my screen. You should be able to see that now. Can you confirm you see my screen? All right, yes. Okay, so hi, good morning again, and good afternoon, good evening. My name is Melchior Almans. I work with Juniper, and one of my interests is in routing security and everything related. So today I want to discuss a potential replacement for MD5 in order to secure long-lived TCP sessions. So let's start with why do we need TCP security? Basically, what we're trying to protect are so-called long-lived TCP sessions. And what is a long-lived TCP session? Examples of those are, for example, BGP sessions, LDP sessions, but could also be RPK RTR sessions, for example. And the reason we're protecting these sessions is against TCP blind insertion attacks and TCP replay attacks. In this, let's say, setting, obviously the place where we're using this most is in Internet Exchange environment, where we're protecting BGP sessions with MD5. So let's quickly look at what a blind insertion attack looks like. In this scenario, we have two routers, router A and B, that have a BGP session in between them, and they have been exchanging routes for a couple of hours. Now we have our node C, so router C, on that same segment, and router C is trying to, let's say, interfere with the BGP session. So what it does, it will send spoofed packets, so it'll spoof router A's IP address. Obviously, the payload it's sending is a TCP packet, where in the header it has the reset bit set. Destination port is obviously TCP 179, and as it doesn't or hasn't been part of the TCP session so far, it'll use random sequence numbers. And it'll try to send those packets to router B. Obviously, router B will discard most of the packets because the sequence numbers are invalid. However, at one point, it'll probably guess the sequence number right, and that could take days, months, or even weeks. But if at that point, when it guesses or sends the TCP packet with the valid sequence number, the BGP session will reset. And potentially router C can now establish a BGP session with router B, but that might not even be necessary. It already interfered with the current BGP session. So that is basically what we're trying to protect currently with TCP MD5, which is working quite well, right? I mean, we probably all use it. However, there are some issues with MD5, but first let's look at how MD5 works. In short, both nodes are configured with a pre-shared key, and the pre-shared key is used to calculate a message authentication code for each TCP segment it sends to the other side. It uses MD5 to calculate that message authentication code using that pre-shared key, and it includes the MD5 signature option in each segment. So the receiving node knows that that specific segment is signed with MD5. The receiving node then calculates the message authentication code for the segments it receives using that same pre-shared key. And if the calculated MAC does not match with the received MAC, it'll discard the packet. So far, so good. However, TCP MD5 has been deprecated for a couple of years now. There are issues. So MD5 itself isn't considered secure anymore. You cannot change the pre-shared key without resetting the TCP session. So in other words, it doesn't allow for dynamic key rollover. And there's no support for multiple authentication algorithms. So there's no way to, let's say, bring MD5 back on par with today's requirements. So we needed to come up with something else. And that something else was presented already back in 2006 at the NANOC 37, where Ron Bonica presented on the topic of authentication for TCP-based routing and management protocols. However, not much happened. Just 4 years later, RFC 5925 was published, and that's the RFC we're discussing here, which is TCP authentication option. And it took another 8 years when Ignas presented again at NANOC in a lightning talk, if we should start considering tcpao to replace MD5. However, there was no running code. So there was no routing vendor that implemented tcpao until late last year, when I had the pleasure to present that back then Nokia, Cisco, and Juniper actually had the code done. And so that's when I started to talk about that it is time to replace MD5. So let's look at this TCP authentication option, where it differs and where it is similar to MD5. The two things I mentioned, which are the most important things, probably why we want to replace MD5, is because it does support for dynamic key rollover without resetting the TCP session. So now if, let's say, someone in your engineering team leaves, you can actually change the key without having to reset the BGP session, and it allows for multiple authentication algorithms. In other words, for more modern authentication algorithms. So if you look at the concept, it's very similar to MD5. It uses a master key tuple, and MKTs are configured on each node, same as with MD5. It uses those, let's say, pre-shared keys, or in this case called MKTs, to derive the traffic keys. A traffic key is used to generate the message authentication code for each segment. So that's very similar to MD5. And it sets the TCP authentication option in the TCP header, and it adds the message authentication code, the key ID that is used for that specific segment, and the received next key ID. In other words, so the other side, the receiving side, knows which key ID to use for the next segment it's receiving. And that is the part that allows for dynamic key rollover. So again, looking into some of the components, we have a TCP connection identifier that is that is built out of the source address, destination address, source port, and destination port. And wildcards are allowed as well. We set the TCP authentication option flag. We have a few identifiers. I already mentioned the key ID that is used for the current segment, and the received next key ID that is used for the next segment. We choose an authentication algorithm. We configure the master key tuples, the pre-shared keys, and a key derivation algorithm. So if you look at the options field, you set option 29, which means I'm using TCP authentication option. And you can see we configure the key ID and received next key ID. And the reason why tcpao allows for multiple authentication algorithms is because the MAC field has variable length instead of fixed length field in MD5. So if you put that together, again, we configure each node with a master key tuple. Each node derives traffic keys from that master key tuple. How we determine which master key tuple is active isn't described in RFC 5925, but current implementations all use a start time and end time, and those can overlap. So that is because you send with the current segment, you send also you send the key ID that's used for that segment, but also the key ID used for the next segment. So that allows for the dynamic key rollover. So again, the procedure, the sending node calculates the MAC for the TCP segment using the chosen authentication algorithm. I have an example of that in a couple of slides where you can see how that is done. It calculates the MAC over the segment with the active traffic key, and it includes tcpao in the segment, so the receiving node knows that tcpao is used. The receiving node calculates the MAC for the segment it receives using the algorithm and traffic key associated with the received key ID. And again, same as in MD5, it discards the packet if the calculated MAC does not match the received MAC. So you see the concept is the same, more or less, but it allows for a couple of additional things. Again, I mentioned already implementation status. Currently, there are 3 vendors who have done the coding and have running code in production releases. So that's Nokia, Cisco, and Juniper. I reached out to Huawei and Arista. Unfortunately, I could not get better statements than we have targeted for Q2 2021 in Huawei's case. And Arista basically told me, we don't know, we're working on it. So in case you're interested and you want to see some of the configuration examples, we started a small repository on GitHub where you can find some of the configuration examples and some results of the IOP testing. And there is a podcast episode from the Roundtable podcast with Ron Bonica and Greg Hankins discussing TCP authentication option. So that's definitely worth listening as well. Question I get a lot is, why not just use GTSM? GTSM works perfectly well in a IXP environment, so on a shared LAN where you only have one hop, right? What GTSM does is you set the TTL of the TCP packet to 255, and the receiver rejects every packet where TTL is less than 245. In other words, it has to come from the first hop, else rejected. So yes, this prevents, let's say, multi-hop attacks, but obviously it does not protect you from first hop attacks. So you still need another mechanism for that. And I'm definitely a big fan of having multiple layers of protection and multiple mechanisms. So tcpao and GTSM go perfectly together. Also, GTSM doesn't obviously protect you from hijack of iBGP sessions, for example. So some IOP testing we've been doing. Greg Hankins from Nokia and myself have been testing tcpao halfway last year. And because of COVID, we obviously couldn't bring easily equipment together, so we used virtual appliances, which actually worked quite well. So we found out that the first thing why we couldn't get it to work is because we were using the same send key ID and received key ID on both sides. That obviously doesn't work. You need to flip one side 180 degrees around. Once we did that, it worked perfectly well. It almost worked out of the box. So we both did quite good coding work, if I may say. And the second lesson learned was an interesting one. Apparently, at first, the VM we were using in Juniper was behind a firewall. And the firewall took the liberty to change the TCP MSS option. Obviously, when the packet was received on the Nokia VM, the MAC calculation failed because of that. So we couldn't bring the BGP session up to quite some time. In the end, it actually proved that tcpao was working. The way we learned it was quite hard because this took us quite some time to figure out, but yeah, it worked. So what's next? Obviously, there's still quite a lot of work to do. Hopefully, other routing vendors will follow soon. The issue is with open source implementations that they need support in the Linux and BSD kernel. So there's definitely work there to do. If someone is interested in helping out with that, please do reach out. We need support in tooling. Work's being done for Wireshark at the moment, but obviously there's more tooling around that would need to be adjusted for tcpao. And I would recommend operators to ask their routing vendors to come up with the TCP authentication option and start asking for that in RFPs and RFIs if your vendor doesn't have it yet, because it is finally time to replace MD5, I believe. And if you're interested in testing, again, please see the GitHub page. Both Juniper and Nokia now have software which is available for download. So the newest releases of the operating system include TCP authentication code. So yeah, so that's available. Any questions? I would.
All right. Thank you, Melchior. Questions? I don't see any questions in the Q&A. Going once.
You can always reach out afterwards, send me an email, find me on LinkedIn, Twitter.
Exactly. That's what I was going to say, that feel free to either send it directly to Melchior or flick it across to, oh, we have one. Melchior, can you see that in the Q&A, or should I read that out for you?
I'm seeing it now. What other TCP applications are planned? Excellent question. So I'm obviously trying to push for RPK RTR because the RFC describes tcpao as the option to use to secure that. This is not a commitment. It's not very high on the roadmap, unfortunately, in our case. But yeah, that's definitely something we're working on. Else, obviously, and I cannot speak for the other vendors, but that is in our case what at least we're looking into.
Thank you for the question and thank you for the answer, Melchior. I guess one thing that Melchior nicely mentioned was looking at the features that are available. Cisco forcing folks to do it only on XR is quite a weird one, because given there are tons of XE nodes out there that are still doing BGP. So maybe please apply pressure to your vendors to get that feature implemented. Thanks once again, Melchior. Thanks a lot.
All right, thank you.
All right, folks. Up next, we have Aftab, who will be talking about, given the amount of routing incidents out there, how many of those are actually intentional incidents and how many of those are fat finger, as we call it. Aftab, with that, the floor is all yours, sir.
Thank you, Tashi. Thank you, Melchior, for joining us so early in the morning. Glad to see you here. So without wasting any time, let me start sharing my screen. I hope I'm sharing the right one, and I hope you can see all that because once I start sharing, I can't see anything else. So I would really like to hear an acknowledgement that yes, I can.
Looks good.
Okay, that's what I want. Right. So as Tashi said, it's more about trying to figure out how many were actual incidents causing problem, or how many were just easy to identify mistakes or fat fingers, which we can all fix quite easily as well. So here you go. So the problem is, I mean, it's if you are attending this session, I think it's pretty clear that you are aware of the problem. BGP inherently doesn't provide you a lot of things to secure your routing. So you have to make sure that you put certain rules in place to make sure that you are not accepting any garbage, or you're not announcing any garbage. So anything other than that, you call it an inadvertent error, or sometimes you call it a fat finger. First, look at the number of incidents we have seen last year. So we published this report as part of the BGP 2020 report, and it is based on one source at the moment. Hopefully, by the end of this year, we should have more comprehensive report collecting from multiple places. But looking at this data from BGP stream, there were quite a lot of incidents which are considered as BGP hijacks. So it's more than 2,400 just in 1 year. Of course, there were multiple bigger events. Otherwise, there were events happening, 10 to 20, 15 events happening on a daily basis. I mean, you can see from the BGP leak side as well that incidents are still happening, whether you like it or not. As a collective, we have, I mean, as a community, we have a collective duty to make sure that we implement certain measures. And this is what we are going to talk about right away. So even yesterday, Awal was talking about that RPK invalids are not going away. I would say the routing incidents are not going away as well. So in last 2 years, from 2019 and 2020, you can see the graph. The daily incident rate is still there. Other than, I mean, we are missing some big high-rise towers, which is very, very good. But still, the smaller incidents we can easily get rid of. Right. So this is what a route hijack looks like, right? So somebody, for example, I have an ASN and a prefix to announce, but somebody somewhere started announcing the prefixes, so we consider it as a hijack. If you just Google YouTube hijack, and you will go to that 2008 incident we are all very famously aware of. So let's talk about the fat finger errors, right? So a couple of I mean, few months ago, I was looking at the data we collect from the BGP stream on the Manners Observatory, and I found some interesting aspects of it. That how much, just trying to understand how many incidents were actual incident caused by somebody playing around with the equipment, or someone actually made deliberate hijack. It's very hard to say at times, but sometimes it is very easy to guess it was just a mistake. And how to figure it out? Well, these are two big examples. On your left side, you can see 3 ASNs, 59355, 59356, and 59365. So you can easily say someone was in a hurry to write down the AS number while trying to prepend. So, and they typed it wrong twice. So their original AS was supposed to be 59356, but they mistyped it 2 other times. And on another occasion, someone was trying to maybe prepend their own ASN 7 times. Rather than doing that, they started announcing AS7. And then I shared that finding on my Twitter feed, and Doug Maderi, we all know about, said, well, it's pretty common incident. Who works, so by the way, Doug Maderi now works for Kenting, and he shares a lot of cool insight about the incidents and the traffic, internet traffic measurements. If you're not following him right now, you should. And he did mention that my friend, and who'll be talking about the RPK in India after me, Anurag Bhatia, did a piece on this in 2013. So that triggered me to figure out how bad the problem is. So I went up to the managers of delivery again and tried to figure out how much incident I can single out, how many incident I can single out they were just mistakes by just looking at what they were announcing. So I said, okay, fine, let's find out how many BGP hijacks are coming from ASN from 1 to 10, or any funny looking AS numbers. So the data was quite surprising, right? So there were like more than 45 incidents in 2018, 2019, 2020, or even in 2021. It is for almost like 40 days of data. Going back from 2018, you can see AS1 was announced twice, AS2 was announced 6 times, AS3 was announced 5, and so on and so forth. And some private ASNs end up in to the routing table. We are not sure how much damage that made, but of course they end up in the routing table. So I tried to look up through the RIPE RIS data and the RIPE stats, and here you can see. It was announced by the private ASN and also captured by the RIPE RIS. One thing I still can't figure it out, that why BGP stream said the detected ASN was 21474XYZ, whereas the announcing ASN was a private AS number. The only explanation I can figure out that this is the maximum number, 21474836447 is the maximum number AWS supports for a private AS number. I'm not sure if that is the case, but this is not clear to me. If anybody has any insight into this one, I would really like to understand as well. Again, you can see people are playing around either in the lab or just trying to prepend and inadvertently sending out AS1 and 2 rather than their own AS number. So we do have we do understand that there is a network operating system in the wild which causes this problem, and everyone I think pretty sure about that one, that why it is happening. So I'll come to that one at the end. Going to the 2019, things are going bad. Now AS1 has been announced 8 times, 2 is 8 times, 3 as well, and 5. And then you can see some interesting AS numbers right at the end as well. So yes, this one you can easily see someone was definitely doing something in the lab. We have all used AS1, AS2, AS3, AS4 in the lab. We shouldn't be using it. No one should be using that, because then you can make a mistake. And they did. And 113, 1113, 1112, they end up announcing it and leaking it to the global routing table. Similar is the case with the two cases. This one is certainly a fat finger. When you have that many zeros in your AS number, I think it's a good idea to copy paste rather than try to type it yourself, because if you try to type it yourself, you end up typing it twice. So this is what happened here. But this one is certainly, again, a lab AS going into the wild. Moving on to 2020, as I said, things are not getting better. AS1 is now 12, AS2 is 12, and the other ASN as well. But the good thing is I couldn't find any funny looking AS number in that mix. I mean, there was no many ones or many twos or anything like that. So in that part, at least things are getting better, but on the 1 to 10 AS number, it's not. You see some really strange advertisements as well. So you can say, I mean, someone was trying to either prepend it for what. First, number one is like 1 time, then 2 times, then 4 times, then 10 times. And certainly it wasn't working. So they keep on trying it so many times. And so this incident happened, if you look at the date, this incident happened first time on 15th of December. And last time when I checked on 1st of February, it was still going out from AS1. And before starting this presentation, I looked it up. It was not announcing from AS1, so it was announcing from its normal AS, that is 135.171. So that problem has been fixed, luckily. And if you look at the data from 2018 to 2021 for AS1 to AS10, the numbers are really very bad. So it's something we should be worried about. And I would say AS1 and AS10, I feel sorry for them, because people assume that they were the hijackers. Well, they were not the hijacker. In fact, their ASNs were hijacked. So they didn't do anything bad about it. So what we learn from this is filtering ASN is as important as filtering prefixes as well. So we have been emphasizing on, okay, do the prefix filtering, but if you're not doing the ASN filtering, it's going to be a problem as well. Create filters before you configure any neighbors. This is what I learned from Philip Smith like 15 years ago. So I think that's still very valid. Practice regex. It's boring, it's complicated, it doesn't work sometimes, but it is very important. You don't have to do unnecessary prepend that many times. So just look at your design, that why you're doing it. Test the lab not connected to your production edge. Make sure that the lab is somehow not connected, so that there are less chances of leaking it. Talk to other people who have been doing this for many years. Philip is there, Tashi is there, other people are there who can help you make that happen. It also shows 2 most important things. One is how easy it is to hijack an ASN. A lot of service providers are not filtering ASN. They filter the prefixes, but not the ASN. That means if you hijack an ASN along with the prefix, you will be negating the ROA. It means the ROA will come out as valid. So that is a troublesome part as well for this whole presentation. So be careful about that. In the manners section, which the first action of the manners, we strongly recommend doing the filtering, not just on the level of prefix, also on ASN. If you want to understand how you do it, then there is an implementation guide available. You can have a look, and in this implementation guide, you can find out the prefix filtering and AS filtering for MikroTik as well. And we believe, and it is a community consensus that as well, that MikroTik, the router OS, is behind most of the AS hijacks, because the way it offers AS prepend. So if you are using a MikroTik, please make sure that you understand how to do prepend before you start doing it. So that is all from my end. And I will just stop sharing and see if there is some question or chat or anything, because now I can look at the chat.
Thank you, Aftab. Questions, I'm looking at Q&A. I don't see questions there.
Cool. This
going
is,
once, going twice.
and I would say.
Yeah, but I guess, so after there seems to be no questions, but I really like your last slide. The lessons learned, nothing fancy there. Anyone who does BGP should be doing those. As you mentioned, Dr. Philip is all of our guru, who used to say, if one attribute doesn't work, maybe that isn't the attribute you should be using. So that applies for your AS path prepends. Probably there are better ways of manipulating your traffic than AS path prepend. Crafting your filters before you configure your BGP session. Hey, that replaces RFC 8212, which is a new feature that's out there to make BGP by default reject. Those are habits that, if people pick up, would help with most of the routing incidents. So with that, Aftab, thanks once again for your time.
My pleasure.
Thanks so much, sir.
Thank you.
Thank you. All right. Folks, please, I would request once again to keep the session a bit interactive. I would request questions, please. So with that, without further ado, moving on, next up, we have our good old friend Anurag out there, not old, good friend, good friend Anurag there, who will be talking about initially started off as his individual push, but later now he's tying it with IronNog and getting few IronNog also roped in so that the message reaches wide to a wider audience. Anurag, great work that you're doing with this. All yours, sir.
Hi, Tashi. Thanks. Can you please confirm if you can see my screen?
Yes.
Okay, perfect. So, yeah, good morning, everyone. My name is Anurag, and I work at Hurricane Electric and based in India. So on Monday, you heard from my colleague Susan about RPK deployment experiences at Hurricane Electric. Today, I'm here to talk about RPK deployment experiences from India and the push we had in India over a period of around last 6 months. So it started from a tweet from my good friend Aval. You might have heard him, I think, yesterday on RPKI invalids not going away. So he pointed in his tweet that when he includes Indian data, the data for South Asia does not look good. If you exclude India, it really looks good. And this was purely testing the RPKI valids visible from country. So as soon as I saw the tweet, I just bookmarked it and I went back on my desktop. So the ideas you get from such a tweets are like, is he correct? And how can you cross-validate that claim? And India has highest number of prefixes as well as ASNs in the region, and that's for obvious size because based on the geographical size and number of networks and the overall population. So can that be a reason which is impacting this result? And if Aval is correct, this is bad. We are going to have really bad publicity for a while. So I looked into it, and he was unfortunately correct. We were really lagging behind. How can we cross-validate the claim? I actually did worked on that, and a large part of this presentation covers that part. So I'll get into the slides in a minute on that. India has high number of resources, but then that should reflect only in the absolute numbers. That should not reflect in relative percentage numbers. So if you look at relative percentage, you should expect to see similar numbers compared to even a smaller a country with a much smaller geographical size. And while it was true, now I am here to talk about a good story. So things turned out not so bad. So starting with validating claim that it was behind. Well, how do you validate RPKI validation for entire country? How can you check how a country is doing with respect to ROAS? Well, one way is just find all the prefixes originated by the country and then run them against a validator. Quite simple, right? Well, as soon as you start working in that direction, you have a couple of challenges. One is, how do you know which prefixes belong to a country? So what should be the starting point? Would you go for a geolocation database? Would you extract only the Indian IPs as per a geolocation database from the global table? Would that even scale up? Then the other part of the problem is, once you identify the prefixes, running them against a validator is actually very slow. If you go sequentially against a validator, it would take like forever to do that. And third part is, of course, how would you store the output and track it over time? Unless you are storing it in a logical manner, the data is pretty much useless. You'll just end up in thousands and thousands of routes doubling at regular intervals. So the way we worked on that was instead of prefixes, you start with ASN. That's a much better option. So mapping prefixes in the routing table against the prefixes in the RIR database is a hard process, because RIR would allocate a larger chunk while operators would announce smaller chunks. But that's not true for AS numbers. So starting from ASN makes more logical sense due to that fact. And then do the ASN to prefix mapping. This approach has a small limitation, which is that you are assuming that Indian ASNs are announcing prefixes in India. There can be small exceptions here and there where, say, a large Indian operator might use Indian ASN outside of India, and so you may be still calculating that prefix, which is not that much. Or you miss the cases where, say, an American ASN, like, say Google or Facebook or Cloudflare, having POP in India, and within American ASN originating, IPs in India, you are going to miss those. But that's an extremely small percentage. Here, the key interest was to actually do it for the large number of operators which are based in India and not exactly multinational. In order to go with the second problem, which is how do you run the check sequentially? Well, we did not. We end up in using RPK API binary. So that's from my good friend Luis. He was working at Cloudflare until recently. He has just left Cloudflare. His project is there on GitHub. I have put the link. So it's an extremely fast tool. It can scan the full routing table in like a couple of minutes. Hardly, I think last time I checked, it was hardly 3 minutes to scan the full table for the RPK status. How do you store it over time? So we just store it in a MySQL database, and then you analyze it using Grafana. More on Grafana in a few minutes. So how we do this kind of validation? So for the table, started using RIS to provide the raw data, and just pull the data every day with the code. So you format the data in a CSV. You can easily extract MRT into a CSV-like format, and then you use query in a GraphQL format, which is required by RPK API specifically. Scan the full table in 3 to 4 minutes. That's super fast. We're not even scanning the full table. We're just scanning Indian prefixes, which happened to be at that time somewhere around 42 to 43,000 prefixes. And lookup is triggered using an Ansible AWX instance. Why not a cron job, you may ask? Well, cron job can do the job, but then it's still tricky. It's hard to scale up a cron job. What if it fails? What if something else breaks up? So Ansible AWX gives you more high-level options of alert on failures, triggering at your will, and a lot of other things. A fair amount of code for this project I put internally at work, not at a country level tracking, but at AS level tracking, because this coincided very near to RPK deployment at Hurricane. This was just about the time when we finished deployment at Hurricane, and we were about to finish deployment at Hurricane, and we were using a similar set of logic for looking at our ASN, looking at our competitors' ASN, just tracking, hey, how large backbone operators are doing with respect to invalids. Is there a sharp drop? And everything here is containerized with Docker. So essentially, whatever I have said is just 3 set of containers. So one, it's just 3 containers. One is doing this lookup. The other is a standard MySQL container storing the database, and third one is Grafana running the graphs. So if it takes a few seconds on India, why not scan the entire South Asia? So it was less than a minute. 44,000 routes, less than a minute. So we ended up in doing that. We just put lots of countries in South Asia, and there were times when I even added other economies from nearby when they asked me on Twitter or email to just start tracking them as well. With this kind of modular approach, I can literally track any of the Appenic members, because I'm starting with Appenic delegation file. If I have to track someone outside of Appenic, I just have to cross-verify how the delegation file differs, if at all. If not, I can even plug in, say, RIPE or Erin for those regions as well. Although I'm not doing that, it just makes more sense to keep keep it focused on certain economies instead of trying to boil the whole ocean, right? You can't analyze that much data. So these were the stats. This is the output from July 2020, the time when I put this tool in production, and I started promoting it. I started tracking on daily basis, going to operators saying, hey, this does not look good. So how was the status at that time? This specific graph is showing you number of valid prefixes against the total prefixes from a given economy. So IN, you can see it was 12% at that time. That was far behind, say, comparing it to Bangladesh at 82%, or Sri Lanka at 90%, or Maldives 99%. So and Pakistan 75%. So it did give an impression that we were really lagging behind, and that was the time when I was under impression that Awal is quite right on that. How the stats now? So this is the graph I just pulled in a few hours ago. So as of now, we have jumped up 43 to 43%. So that's 12% to 43% over this time. Minor changes in other economies around, and that's quite obvious. Once you reach 80% plus levels, you have got large number of operators covered. So I cannot imagine a lot of South Asian countries jumping into 100 immediately. It's easy to go from say 0 to 30, 30 to 60, and so on. As you come near to 100, it becomes much harder, because now you're looking at super small, lots and lots of ASNs. Here's the graph when you're tracking this. So blue line, you can see that's India. So we were in terms of absolute valids in Asia, we were far behind many other economies. We crossed that sometimes around August, and then there are times when there were some major jumps. So this was a jump when one of the large mobile telcos signed. There were jumps when a couple of backbone operators signed, and so on. So this is the graph for absolute prefixes. We went up from sometimes something around 5,000 prefixes to close to 20,000. I think it's somewhere in 19,000 range right now, which are RPKI signed and valid. We are not tracking invalids, in this graph. Here's the case for percentage. So percentage, we went from 12 to 43, as I said. Invalids, well, that's an interesting story. Invalids, our experiences have been extremely bumpy. You can see there were times when we got them really down. There were times when they still come up. Funny enough, just 24 hours ago, in the last check yesterday morning, there was a major jump in invalids due to one of the operators getting lots of them. So it remains bumpy when operators with 10,000, 18,000 prefixes start creating ROAs. Many of them do not have enough documentation on where those IPs are going. Some are going to their own sister organizations. Some are even delegated to their downstream customers who are originating those, and all that adds up to the invalid. So quite actively working out with operators, via mailing list and emails, and spamming them at regular intervals about it. Here's a brief timeline, and this is not a sharp timeline. This is just giving you a macro idea, because most of the operators mentioned in this list, it took them a while to create ROAs. So no one did it in a month. They started at some point, but this was the time when a large part of their table was signed. So Tata Communications, AS4755, the Indian backbone BSNL there. So they signed a large part of almost all of their Indian table. Then Reliance Jio signed most of its table in September. Reliance Jio has much lesser prefixes by design. In IPv4, they have much lesser prefixes, and in IPv6, you can aggregate well. So you may have lots and lots of customers, but still lesser prefixes. So the jump wasn't visible that much, but the impact was very high. They have extremely high amount of user base. So Tata and Jio covering up, that was very nice. Then National Informatics Center, which is like an ISP for Government of India. They're in data centers, and lots of government content of state and central government is hosted on their network. They signed their prefixes, all of them, sometimes in October. Then BSNL, the large incumbent AS9829, they signed half of its table somewhere around November. They're still working on signing the remaining part. I'm assuming it's going to be in next maybe 1 to 2 months once their entire table is signed. And then sometimes around December, Airtel Mobility signed large part of its prefixes, and there also the jump was visible. So out of 3 large mobile telcos, 2 have created RPKI ROAs for a large part of their table, excluding the third one. So this went from this was this kind of major signing of creation of ROAs resulted in this jump. Is this a jump just because of large operators with lots of IP assets? Well, the answer is no. Here's a comparison I just pulled in a few hours ago as a reference point. So here what we are looking for is the unique ASNs with a valid ROA in the Indian table. So on 14th July 2020, the number was something around 328 on the left side of the graph. You can see the data does not have origin ASN because this was a feature we added, at a much later stage. At that time, I was just, in hurry to just bring it up and actually validate Awal's claim. So as the time proceeded, I did multiple other things. When you look at this data now, which is from the check which ran less than 24 hours ago, the number has jumped up all the way from 328 to 834. So large number of, close to 500 ASNs have added in the list. So it's not just, a couple of large telcos. I did mention the large ones because they were the ones where the impact was high. But, the smaller ISPs, smaller operators are extremely important, and they have done a fantastic job of, of going ahead with this. Some more details about Grafana, the tool I'm using, and the data is online. You can always visit rpki. My full name anuragbhatia.com. So that's actually points to a publicly hosted Grafana instance, and it acts as a nice front end. You can display any sort of data in there, and it supports different sort of sources. So you can point it to InfluxDB, MySQL, or any other kind of database, and it can typically plot any kind of time, time data where something is against a time or some kind of absolute data. And it's open source and free to use in a self-hosted format. So we are just self-hosting it. It comes pre-packed as a Docker container. So we are using its official Docker container for that. It can be used for many other tools. I also used it on RIPE Atlas, data analysis as well a while ago, where I was trying to import lots and lots of data and analyze, how the latency is performing across different networks. It supports authentication. So if you want to run it in a closed environment, you can always do that. It will ask you to log in and your other members to log in, or you can make it totally public without any authentication, which is the case for the RPK tool right now. As we were proceeding with that, Sunny reached out and from AppNIC, and we started interacting more, and we end up in starting a program called RPK India 2020. So this was the early phase. I believe it was sometimes around August 2020 when AppNIC, IRIN, which is the Indian NIR, and then ISPI, Indian ISP Association, and a few of IRNOC volunteers like me, we started promoting RPK in India. We started conducting regular workshops to cover RPK ROAs. We're conducting these sessions over Zoom. These were all free to attend. So this was still, kind of lockdown time, and people were available to people were curious to learn interesting technologies. Content is built from ground up, so we put most of content, from scratch instead of relying on other slides. But we have a large part of our slides are referencing to rpki.redocs.io. It's a fantastic documentation on RPKI, and live demo is based on FRR and Routinator. So we set it up on FRR with Routinator. We create a lab scenario essentially announcing valid, invalid, and unsigned, and just creating a lab environment of faking a leak and faking a hijack and trying to detect it and drop it with RPKI. And apart from that, it started with regular emails and phone calls to network operators, excessive emails at times, I must say. One thing I lost out of this process was, some of the good friends who I bothered too much, by spamming them at regular intervals to fix their ROAs. And it is like that. It's a fair trade-off you have when you start something like that. So that's about it. Any questions?
Right.
Or suggestions?
Thanks, Anurag. Couple of questions out there, Anurag. Let's take the first one from Dave. Can you see the question, Anurag? But thanks a lot, Anurag. And once again, kudos to your effort. And we can definitely see, you're not making up the story. We also monitor it. We can definitely see quite a drastic jump in India. First question from Dave, Anurag, reading it out for the audience's benefit. A portion of the Indian market claim that RPK is difficult for them due to the size of their networks, given how big certain Indian networks are. But again, that shouldn't be an excuse for sure. What is the relationship between bad BGP aggregation that we see in India and RPK adoption? From Dave for Anurag.
I think bad. So first part, I totally agree. It can be difficult. I think it has less to do with the size. It has more to do with other mostly the economical factors of high tariff war, resulting in much more cutthroat pricing, and eventually quality and the engineering resources end up in suffering due to that. So it has more to do with those kind of things probably. On the part about deaggregation, well, yeah, deaggregation has an impact, because when people deaggregate too much, it becomes hard to track prefixes. When I was looking at super large telcos, I was asking this question: why are they announcing 10,000, 15,000 prefixes? What's the point? These are not the networks who would buy like a gig link here and a gig link there and would try to multi-home. These are the ones with lots and lots of 100 gig links. So it doesn't make sense. And it feels like somehow in South Asia, this is a more common trend where people are deaggregating a lot more than they should. The only thing we can do about that is probably start promoting, start working on more on workshop, promoting, good practices to deal with that. I think that answers that.
Yes, Anurag. On to the next one.
Mm-hmm. Sure. Good work. It looks like you have covered major ASNs in India. Who else is left in 60%? Well, lots of them. Lots and lots of small ones. In terms of large ones, as I was saying, BSNL has half of their table signed. Remaining half is still a pretty large chunk of their table. So BSNL is still left out. Then Vodafone and Idea, which merged a while ago, they are still out of that. And so that's on the larger ASN side, but there are lots and lots of smaller ASN. And when I say smaller, these are not 1 or 2 prefix originating ASNs. These are still 50 or 100 prefix originating ASNs. So we are trying out different things. So things like regular workshops. Plus 3 days ago, I started classifying all the prefixes against RIR. So now I'm mapping them. Which do they belong to Apinic or do they belong to IRIN, and trying to push respective RIR to do their job. And maybe at this point of time, I should also say one part of problem is lack of tooling at RIR level, especially for invalids. I wonder when people make a major change in their ROAS at RIR should have the checks enabled. They should be able to figure those out. Let's say I'm an operator and I'm making a change in my ROAS, and suddenly things go bad. If I receive an email within an hour or two max, I can understand there'll be limitation because you're collecting data from some open repository. So if I get an email in 1 or 2 hours, hey, suddenly your invalids have jumped up from say 0 to 100, I would act immediately. So and when this email comes from RIR, I won't question, hey, who are you? Which is a funny and embarrassing question, which at times I got while promoting RPKI. Well, who are you and why you are making us?
Who are you? Yeah, Anurag, I think your last point is a solid one. And this is something I'll carry back to the registry product team, Anurag, as in because there is already a route management system. So it's a matter of getting few labels and notifications attached to it. Yeah, thank you so much, Anurag. And about that granularity you were talking about, as you were speaking, I was looking at an internal tool that me and few colleagues run, similar to yours. Under Apinix Trust Anchor, we see 201 routes, IPv4 routes from India as being invalid. Under the IRIN Trust Anchor, we see 109 under the IRIN delegation. And the top invalids are all your top major operators in India. Airtel Broadband AS24560 has 98 of their routes are invalid MaxLink, but their ROAs are /16, all 24s are being announced, 33s are being announced. Easy fix. Connectivity wise, maybe they don't have an issue because there's a covering aggregate ROA for that. So
and that similarly, answers question from Yahya. Yahya just asked this question. Well, were there reachability issues? Well, there were reachability issues only for smaller operators which were not aggregating. For large telcos, they were usually aggregating. So there were not reachability issues. But at the same time, I think now after large transit-free ASNs have started dropping invalids, you will get into a serious reachability issue if you have invalid at this point of time, if you don't have a covering prefix.
Yeah, exactly. You may not have that path predictability for sure, but you won't have reachability issue. So Tata similarly. So Bharti, I think, is easy fix. Reliance, they seem to have multi-ASN. So it seems they have created ROA only for the transit AS, but we see it being originated out of AS 17803. So yeah, I think granular level, while we are seeing nice uptake of RPKI, similar to what you mentioned about your invalids graph, it's that sawtooth kind of map where all of a sudden there are less invalids, but again, there is quite a spike, MaxLink or multi-ASN networks. But yeah, Anurag, once again, great work there, mate. And thanks for this. And Jack has a question in Q&A. Just last question. Nice visualization, Anurag. Any action taken for the invalids from ISPs in India?
We were just, set of volunteers, so we could not take any action as such. The internet is quite distributed. So we used to mail them at regular intervals. We would try to reach out. There were times when we could not reach them through email or they did not respond to email. Then I used to try out ways. I used to look at my, friendship BGP table and see, hey, do you hear this ASN from any of your friends? Do you know friends out there? Can you introduce me? And that sort of thing. I think once 2 or 3 large Indian telcos start dropping invalids, there would be extremely high level of impact, because India, unlike say Singapore or many of the countries in Europe where there's a lot of interconnection, in case of India, a large part of traffic goes out to the world from only 5 or 6 large ASNs. So once a few of those start dropping invalids, the impact would be very high. Connectivity would be seriously crippled for invalids, and at that point of time, everyone would realize and would start fixing that.
Thank you once again, Anurag. That's a wrap from our side. Thanks once again. Trouble with that, Philip? I'll hand it back to you, sir.
All right, thank you to all the speakers. So before we wrap up this session, I'd like to remind everyone that there is still some room for lightning talks. The session is tomorrow afternoon, and the deadline is 5 o'clock this afternoon, Manila time, which is, I think, about 3 hours from now. So with that, reminder, the session was recorded, so you can watch it again at your leisure. You should also fill in the poll, which should have popped up on your screen a second ago. And if you've got any questions for speakers that weren't answered, please email them to us and we'll forward them to the speakers. The next session, I believe, is the network ops session after lunch in about 45 minutes. So with that, thank you very much, everyone.
Thank you.